Hello everyone, welcome back to Cambridge Guru once again. As you know that we are doing AP Calculus lecture series. This is the fifth edition of the lecture series and we have already covered 4 lessons. The previous lesson was about the polynomial functions, in which we talked more about polynomial function, and specifically we did the quadratic expression, in which we learned how to solve a quadratic equation. We also learned how to solve a quadratic equation using completing the square form, which is very important in analyzing any quadratic curve. We also did the graphical analysis of a quadratic expression. In which we did that any quadratic function is a kind of a parabola, and by writing the expression into completing the square form, we can find out the coordinates of the vertex of the parabola. This all we did, right? Moving ahead, in this video we will talk about more type of functions, and in which more specifically we will talk about the exponential and logarithmic function. So without any delay, let us start with the next topic, which is exponential function. Exponential function. We must have encountered any type of function of the type y is equal to half raised to power x, y raised, or it can be 2 raised to power x, or it can be 3 raised to power x, e raised to power x. All these are called exponential function, in which the variable or the independent variable is in the exponent of any number, right? So any function of the type a raised to power x, we define an exponential function of the type y is equal to a raised to power x, where we say that a is the base, right, and x is the variable or the exponent, right, this base a. Now there are certain conditions in order for any function to be called as an exponential function. What are those conditions? Is that this base a should be greater than 0 and it should not be equal to 1. Base a should be greater than 0 and it should not be equal to 1. Now let us analyze one by one that why we are defining these conditions, or why the negative value of a is not allowed, and why the value of a cannot be equal to 1, right? By simple logic, you can say that condition 1, that if a is equal to 1, then our function y will be of the type 1 raised to power x. And as we know that whatever is the value of the exponent, this function will always give you the value of 1. So we cannot call this as an exponential function, right? So this value of a cannot be equal to 1. Base value cannot be equal to 1. This is our first condition, right? And for the second condition, that if a is, let us say, negative, and for example, let us say value of a is minus half. Okay, so our function will be of the type y is equal to minus half raised to power x, right? Now clearly, since base is negative, the answer will be of two types. It can be either greater than 0 or it can be less than 0. Why I am saying this? Because depending upon the value of the exponent, answer will be either positive or negative. Now think logically that if, let us say, I say minus 2 square, right? What is the value for minus 2 square? So minus 2 square is just plus 4. But if I say minus 2 cube, then the answer will be minus 8. So similarly, this will be equal to, value will be positive. We say that if x is an even number, right? For example, minus half raised to power 2 will be equal to 1 by 4, or minus half raised to power 4 will be 1 by 16, and so on. Because exponent is positive, so base, negative base will be nullified. Now just the reverse of this, that the answer will be negative, we say that if the exponent x is an odd number, right? So minus 1 raised to power 3 or minus 1 raised to power half is minus half, minus 1 by 2 raised to power 3 is minus 1 by 8, and so on. So if exponent is an odd number, answer will be negative. If it is an even number, answer will be positive. So exactly how you will define this exponential function? So we cannot define this function exactly, right? Depending upon the particular value of x, you are finding out particular value of y. But specifically, you cannot define the function as an exponential function. That's why this condition is must, that this base should be positive and it cannot be equal to 1, right? So these function, example, that y is equal to half raised to power x, this is allowed. This is an exponential function because it is satisfying this condition, right? If there is a confusion, there might be some confusion that this value is, if it is not equal to 1 but it is less than 1, yes, because there are infinite numbers between a greater than 0 and a should not be equal to 1. So the value of a, that is, a can take value between 0 and 1. This is allowed. Okay, this value is allowed. So we can take any fraction value between 0 and 1, right? So this is an exponential function, but if you write minus 2 raised to power x, this is not an exponential function. And obviously, if a is greater than 1, then you will get the function of the type 3 raised to power x, 4 raised to power x, 4.5 raised to power x, and so on. Okay. So this was the basic definition of an exponential function. Now, let us analyze the graph of these functions. Now, if you have y is equal to a raised to power x, there will be two types of graphs depending upon the base a. Okay. Right. So if a is, this is the case 1, if a is greater than 1. Now that condition is coming with us, that you cannot take a as negative and a as 1. So we are taking a as greater than 1. So of the type 2 raised to power x, 3 raised to power x, 4 raised to power x, and so on. So graph of that function will always be an increasing function of this type. Okay, this is a raised to power x if a is greater than 1. So 2 raised to power x, 3 raised to power x, and so on will be of this type. Now this y-intercept will always be equal to, you can guess this value, that if x is 0, you put x equal to 0 here. So a raised to power 0 will always be equal to 1, right? So this y-intercept will be 1. Okay, and as you can see, that the domain of this exponential function is all real numbers, right? There is no value of x. We haven't put any condition on the exponent of x. In all these conditions are related to the base of the function, not on the exponent. So you put any input variable x, the function is properly defined, right? So if we talk about the domain of this f, the domain is x belongs to R or real numbers. And when we talk about the range of the function, range of f, so it is always greater than 0. Okay, so fx or y is always greater than 0. It will be 0, it will approach to the value 0 when this exponent will be minus infinity, because if it is minus infinity, it will be of the type a raised to power, or let me give you an idea, that y is equal to a raised to power minus infinity, meaning you can write this as 1 by a raised to power infinity. This means this can be approximately equal to 1 by infinity, so it will approach to the value 0. So when x is negative infinity, value of the y is 0. It will approach towards 0, and when x is infinite, value of y will be a raised to power infinite will be infinite. So hence the graph is like this. Okay, it is a continuous graph, right? And the reverse of this is the second case, when a is lying between 0 and 1. So the function of the type half raised to power x, 1 by 3 raised to power x, 1 by 4 raised to power x, all these, right? Now you can analyze the shape of this curve by taking an example of the type half raised to power x. This can be written as 1 by 2 raised to power x. Now you keep on increasing the value of x, denominator is going to increase, so the whole fraction is going to decrease. So half raised to power x, 1 by 3 raised to power x, or for second case, the function will be a decreasing function like this. The function will be decreasing function, and similarly, this y-intercept will again be equal to 1. Now in both the cases, you can see that the value of the exponential function, whether base is between 0 and 1 or if it is greater than 1, the value of the function is always greater than 0. Exponential function cannot go below the x-axis. It will always remain above the x-axis, right? So exponential function are always greater than 0. Just remember this. So when we talk about the range of this exponential function, it is always greater than 0. Yes, it can approach to the value 0 when x is either minus infinity or plus infinity, depending on the value of a. Okay, so this was all about the exponential function. Okay, now second part, it's just the brother of this. We say that the second type of function we will talk about is the logarithmic function. Now if you have heard about the inverse function, right, so we say the log function and exponential function are inverse to each other, right? So next topic we will talk about. So this was the graph of these exponential function. You can say that, see that 2 raised to power x is increasing and half raised to power x is decreasing, right? So next function we will talk about is logarithm function. Right? Now consider this fact, not fact, but this scenario, that when we say that y is equal to 2 raised to power x. Now this x, as you know, is called an independent variable. So when we keep on changing the value of x from 0, 1, 2, 3 and so on, you will get the value of y as 2 raised to power 1, 2 raised to power 2, 2 raised to power 3 and so on. Meaning 2, 4, 8, 16, 32 and so on, right? So that means you know the value of input, you are giving the input to this function, you are finding out the value of y. Simple. So this is our exponential function which we have talked about. What will be the reverse process for this is, you know the output. For example, that if you're writing an equation of the type 2 raised to power x and you know the value of the output, which is, let us say, 32. Okay, so in this case you need to find out the value of input, you know the output. So by simple logic you can say that 2 raised to power 5 is basically 32. So you can find out directly that x value is 5. Similarly, if I take 2 raised to power x as 16, you will say that value of x is 4, right? So as you can see here that the process now is reversed. Okay, just keep this thing in mind. Now if I take another value, that what will be the value of x if the answer is 20, right? Now you cannot find out directly the value of this x because either you know the integer value of x, 2 raised to power 4, 2 raised to power 5, 6 and so on, but you cannot find out exactly in your mind the answer 2 raised to power 4.5 or 4.7. Okay, but definitely you can say, see here that since 2 raised to power 5 was 32 and 2 raised to power 4 was 16, and this 22 is lying somewhere between 32 and 16. Therefore, this x should lie between 4 and 5. I am repeating, we are talking about this equation, that since 20 is lying between 32 and 16, so this x should lie between 4 and 5. But again, exactly you cannot find out the value of x. Okay, it will lie between 4 and 5. Now how to find out exactly the value of this x? Now here comes into picture the function which is called the log function. Okay, so this was the idea that log function and exponential function are in fact inverse of each other. Now let me show you another scenario that if we have a number 32, okay, if you have a number 32, there are two ways to write this number 32. Number one is you can write this as 2 raised to power 5 as 32, and this is called as an exponential form, which we have just learned that 2 raised to power 5 is 32. Another way of writing this is that I write this as log of 32 with base 2, because in exponent base is 2, so here we say that log 32 with some number 2, we call this as base 2, is equal to 5. So this is exponential form of writing 32. This is logarithmic form of writing 32. And both these exponential and log function are inverse of each other, right? This 2, as we know that this is called this was the base of the exponent, so we say that log 32 with base 2 is 5. That is the way of saying this equation. Log 32 base 2 is 5, right? Now again, so any function of the type y is equal to log a with base b. Log a with base b is called a logarithmic function. Now just like we defined certain conditions in exponential function, likewise we defined some condition for the log function also. This 2 was the base in exponent function. We are calling this as the base. So whatever the condition of were applied to the base in exponential function, same condition will be applied to the base of logarithm function. So we say that this base b should be greater than 0, it should be positive, and it should not be equal to 1. This was the condition on the base, right? And the second condition is, since we know, if you look closely here, in the exponent function, this was the answer, this was the output of the exponential function, and we just talked about that this output will always be positive. This output for an exponential function is always positive. In the log function, this becomes the input, 32, right? So condition on log function is that this a should be positive. Okay, so this a should be positive. These are the two conditions for any function to be called as a log function. If you need to find out the value of, or you can find out the value of only positive number, log of any positive number, provided that condition on base should be that its base should always be equal to, no, it should always be greater than 0, and it cannot be equal to 1. Okay, so this was the introduction of log function, right? So you remember I gave you one example that what will be the value of this x, or solve this x, right? So now this is an exponential form. Converting this into log form, you can say that log of 20 with base 2 will be equal to x. That is how you find out the value of x exactly. Not exactly, because all these will be the irrational numbers, and mathematicians have developed certain log tables, right, in order to find out the log of a number with base. Nowadays we seldom use log tables because we have the log button in our calculator. We can find out log of any number with any base using the calculator. Okay, so I'm not here to teach how to find out log using log tables, right? There is Abscisca and there are Mentesa and so on. We're not talking about that. So just to give the idea of the range and domain for log function, we are talking about that. Okay, so log of 20 with base 2. Now what will be the domain? Since I said that this a should be positive and this a is our input, so domain for log function that this domain is always positive. And when we talk about the range of the function, the range of log function will be all real numbers. Range of this will always be any real number. Why? Again, considering the fact that in the exponential function input, which was x, there was no condition on the input x. It was defined from minus infinity till plus infinity. Similarly, for the log function, input becomes the output. So, range of a log function will always be all real numbers. Talking about the graph of log function. So, graph of the function log will be of the type will be like this. Okay, this value, can you tell me the coordinate of this? Yes, you have guessed it right. It is 1, 0. There is no y-intercept in log, just like there was no x-intercept in exponential function. Okay, so here only you can get some idea about, we will do some inverse function later on, but you will get some idea of inverse function, that input becomes output and output becomes input, right? So here was the y-intercept, which was 0, 1. It becomes 1, 0 in the log function. Okay, so as you can see, the range is between minus infinity till plus infinity, and domain is just positive numbers. 0 is not allowed. Log 0 is minus infinity. Okay, now there are some properties for log function which will be used in solving certain question involving logs. Okay, what are those properties? So you can write down if you are making some notes. Properties of log function. Number one property is, if you're taking log of a with any base plus log of b with any base, not any base, these bases must be same. So you can take base as x. Okay, let me write this log as x and y, because input we are talking in terms of variables, so we'll take variables as x and y, right? So rewriting this as log of x with base a, you are adding then log of y with the same base a. What you can do is that you can first multiply these xy, okay, then you take the log with same base a. This is your property number one, that log x plus log y is equal to log of xy. Do not get confused, right? Student, they get confused that log of x plus y, they write this as log of x plus log of y. This log is not in the multiplication of x and y, right? So this is wrong. This is wrong. And similarly, they also write this as log x into log y as log x plus log y. Okay, this is also not right. Right? Log x plus log y is log xy. First multiply the numbers, then you take the log. Here you have taken the log separately, then you are adding. That is the difference. Okay. Second is, just like if it is plus, we have addition. So you can guess the second one, that if you are subtracting two logs, log x minus log y with same base a is equal to, in this case, multiplication becomes division. So log x by y. This is the second property. Okay. Third property is, you can guess, not property, this you need to remember, that log of what can be the log of 1 with base a? What can be the log of 1 with base a? This is 0. because converting this into exponent form, okay, yes, I need to tell you this also, how to convert log into exponent form and exponent into log form. Exponent into log form we have talked about when we were dealing with the case of 32, how to write 32 in exponent in log form, right? So when we have to convert log into exponential form, what we do is we took this base, right, and put it in the feet of this 0. That is how I remember, right? So 1 is equal to a raised to power 0. Put this 0 on the shoulder of a. The moment you transfer this a to RHS, right, this 0 is on the shoulder of a. So a raised to power 0. This is the exponent form, right? That's why log of 1 with any base is equal to 0. Okay. Fourth property, which is very, very important, that if log of x with some exponent n is written, right, with any base a, right, as you have seen here, this can be written as log of x into x into x into x n times, and times I should write, right? Meaning is using property 1 that log of x into y is log x plus log y. Writing this result in reverse form, you can write this as log of x plus log of y, log of x plus log of x, and so on. How many times? N times. Meaning you are adding n times log of x, so this can be written as n times log of x. And this is a very, very important result that you will use in log, that log x raised to power n is n log x. Okay, this exponent comes in the multiplication. So if I take the example that we have to find out the log of 3 raised to power 100. So 3 raised to power 100 is a very, very big number. How you will evaluate this? So simple way is writing this as 100 into log 3. Just evaluate log 3, it is very simple, and then multiply that value by 100. Okay, this is how you do or apply this property. Okay, so this is all about the exponential and log functions. I hope you enjoyed this, and in the next video we will do some questions involving exponential and log questions or equations. Till then, take care. Bye bye. See you soon.